All right, good afternoon. Doing this video to go over 2D part two, kind of an extension of our first 2D notes. So, first thing, formula for finding a point, fractional distance from two endpoints from our 2D notes. Okay, so x3 is going to be equal to x1 plus k times parentheses x2 minus x1. Okay, and then y3 is y1 plus k of y2 minus y1. Okay, and all that is if we have a line segment, two endpoints. So if we start at x1, y1, and we end at x2, y2, that point in the middle is going to be our x3, y3. Okay. So remember, x1, y1 is our start. All right. x2, y2 is our end. Okay. All right, so what we're going to do is going to be the same equations here, but we're just going to have to work them backwards. Okay. So on a number line, suppose we have coordinates of negative 13 and positive 19. So we have negative 13 and positive 19. And we want to find out what fraction of the distance point negative 5 is from 13 to 19. So we have negative 5 here. Okay. So we only have one dimension. So this is kind of our x1. The 19 is our x2. The negative 5 is our x3. And we're looking for k. We don't know what our k is here. Okay, so we're actually trying to find what fraction. So what fraction is going to tell us that we're going to look for k. So we should have x1, x2, and x3. Okay, so x3 is negative 5. Right, x3 equals x1, negative 13, plus k, then x2 minus x1, which is 19 minus 13, minus negative 13, excuse me. So what happens here, if we were to simplify this down, we get negative 5 equals negative 13 plus, now 19 minus negative 13, which is really 19 plus 13. Okay, 19 plus 13 is 32. And we're still multiplying k by it. All right, so negative 5 equals negative 13 plus 32k. So we want to get k by itself, so we plus 13 and we plus 13. All right, so what we get, negative 5 plus 13 is 8 equals 32k. So our k is going to be 8 divided by 32. All right, so k is 8 divided by 32, which simplifies to 1/4. Which tells us that this point negative 5 is 1/4 of the way from negative 13 to 19. Okay, we're still setting up the same equations that we have here. X3 equals x1 plus k, x2 minus x1. Except now, instead of not knowing x3, we don't know k. So we're going to plug in a number for x3, plug in a number for x1, x2, x1, and then solve for k. So if we're to ask what fraction of the distance is negative 9.2 and 9.5 is a point negative 3.3. What's cool is we only have to do our x, our x's. We don't really have to do x's and y's. We just do it once. So negative 9.2 is x1, y1, negative or 9.5 is x2, y2, 0.33 is x3, y3. Okay. So remember the formula, x3 equals x1 plus k times x2 minus x1. Same formula we saw in the 2D notes. All right. So to give us our x3, which is our point in the middle, which is -3, our x1 is -9. We don't know our k. X2 is 9. X1 is -9, so 9 minus -9. All right, so we simplify this out. So -3 equals -9 plus 9 minus -9 is equal to 18. 18 times k is 18k. So -3 equals -9 plus 18k. Got a plus 9 on both sides. So -3 plus 9 is 6, and that's equal to 18k. So divide by 6 and divide by 6, or divide by 18, I'm sorry. Divide by 18 to both sides. K is going to equal 6 over 18, which is 1/3. All right, try those next two problems out on your own. Next, let's say we're given our fraction, our endpoint, and a point at a fractional distance. So now we're given x1, y1, and then we're given k, and we're given x3, y3. Now we got to solve for our x2, y2.